Good morning, ladies and gentlemen, and welcome to Chapter 11, Section 8, Factoring a Polynomial Completely. As you can see here, our notes start with a checklist. And earlier in the chapter, we started with learning how to factor the greatest common factor out of a polynomial. We looked for a common term in each part of the expression, and then we factored it out. The answer looks like a GCF problem. Then we factor difference of two squares by taking the square root of the first and last terms, putting them in parentheses with a plus minus. And then factoring by grouping was used to factor trinomials, and we spent a couple of days on that. We did that yesterday. You'll notice number 4 here, difference of squares, is listed twice. It is not uncommon in a factoring completely problem for you to have to factor the difference of two squares more than once. So factoring completely, we're going to use this checklist. We're going to factor in that order. Some of the things we'll have to skip because they won't be there, but we're going to always try to factor out the greatest common factor first. Take a look at problem 1, which has been completed for you. by squared and 4b have a b common to both terms. So we're going to factor the b out. We divide both by b. We're left with y squared minus 4. That gives us b times y squared minus 4. Y squared minus 4 is difference of two squares. Y squared is a perfect square, 4 is a perfect square, and there's a minus sign in between them. We take the square root of y squared, it's y. We take the square root of 4, it's 2, and then we put in plus minus. This is the factored form of by squared minus 4b, factored completely. We can multiply all that back together to check our work, and we will get the original expression back. 5x squared minus 45. Take a look at the first term and last term. There's no x's after the 45, but there is 5 common to both of them. So we'll take the GCF of 5 out. 45 divided by 5 is 9. So we're left with 5 times x squared minus 9. GCF, we took it out. Step 2, is this difference of two squares? Well, the square root of x squared is x. The square root of 9 is 3. So they are perfect squares, and there's a minus sign in between them. So the way we factor difference of two squares, square root of x squared, square root of 9, and then we throw in a plus and a minus. This is the factored form of 5x squared minus 45. GCF followed by difference of two squares. That was a two-step problem. Problem 3, take a look at all three terms. You might want to take an x out, but notice there is no x after the 24, so that's not going to work. 3 goes into 6, 3 goes into 24. Let's take the 3 out. So we're left with 3 times x squared. Negative 6 divided by 3 is negative 2. Negative 24 divided by 3 is negative 8. Okay? So I got a trinomial here. I'm going to factor by grouping. So off on the side, I want factors of negative 8 that add to be negative 2. So let's see. Negative 4 times positive 2 is negative 8. Negative 4 plus positive 2 is negative 2. So I'm going to do this factoring by grouping that we've been doing for a while here. However, I'm going to keep that 3 out in front of the whole thing. Alright. So let's see. Common to x squared and minus 4x is an x. Common to 2x minus 8 is a 2. And then finally, I'm going to take x minus 4, x plus 2, and notice that 3 is out in front of the whole thing. 3 times the quantity, x minus 4, times the quantity, x plus 2, is the factored form of 3x squared minus 6x minus 24. Take a moment and FOIL x minus 4 times x plus 2. Once that's done and completely simplified, multiply by 3. That's how you check your work. Problem 4. Alright, let's see here. No x after the 32, so I can't take an x out. There is a 2 common to both, so I'll take that out. 2 times x to the 4th minus 32 divided by 2 is 16. Alright, well, Possibly difference of two squares here. Let's see. The square root of x to the fourth. Remember, we take the square root of even exponents by dividing the exponent in half. Square root of 16 is 4. So this becomes 2 times x squared plus 4 and x squared minus 4. Now you might think that's done, box it up and walk away. However, take a look at x squared minus 4. That actually can be factored again. The square root of x squared is x. The square root of 4 is 2. So this becomes 2 times x squared plus 4, just bringing down the stuff I didn't touch. But what I have circled here is going to be x plus 2 times x minus 2. This is a factored form, 3-step problem of 2x to the fourth minus 32. And you can multiply all that together to check your work. You kind of do it in the opposite order in which you took it out. Number 5, no r after the 48, but 4 goes into 48, so I'll take 4 out of all these. So that's 4 times r squared minus r minus 12. Alright, so for our puzzle here, we want factors of negative 12 that add to be negative 1. So why don't we try 4 and 3? Let's decide what we need to do for a sign here. I want them to add up to be negative 1, so how about negative 4 and plus 3? So let's see. We have then 4 times r squared minus 4r plus 3r minus 12. Alright, just keep that 4 in front of the whole thing the whole time. So this is 4 times, common to those two terms is an r, common to these two terms is a 3, and our final answer I'll put over here just for space reasons. 4 times r minus 4 times r plus 3. So that 4 you took out, that GCF you took out earlier, just going to stay in front of the whole thing. Don't lose it. You don't want to misplace it because it does have to be part of your answer. Problem 6. Alright, let's see. AB sticking out here. I'm going to take an AB out of both of these. If I take AB out of ABx squared, I'm left with x squared. Negative AB divided by AB is negative 1. GCF. Factor that GCF out. X squared minus 1 is a difference of two squares. The square root of x squared is x. The square root of 1 is 1. Throw in a plus minus. GCF followed by a difference of two squares is pretty common. Problem 1, problem 2, and problem 6. We've seen that. Alright, number 7. 4x squared minus 6x minus 4. There's no x after this 4 at the end, so I can't take an x out. 4 doesn't go into 6, so I can't take 4 out, but I can take a 2. 2 goes in all of those. 4 divided by 2 is 2, x squared. Negative 6 divided by 2 is negative 3, x. Negative 4 divided by 2 is negative 2. So I took that 2 out, now I have a trinomial to factor. So let's see, AC, 2 times negative 2 is negative 4. Remember, A is 2, B is negative 3, and C is negative 2. And this is A times C up here. B is negative 3. This is B. So, factors of negative 4 that add to be negative 3. So different signs to give us that negative 4. How about we go 4 and 1, and we'll make that 4 negative, and that'll do the job. So let's see, we got 2 times 2x squared. Instead of negative 3x, we're going to go negative 4x plus 1x. And then that minus 2 will carry down. 2 times, let's see, common to 2x squared and negative 4x is a 2x. And then we don't want this to change at all, so we're just going to take out a plus 1. So final answer, 2 times x minus 2 times 2x plus 1. Alright, and of course we can multiply all that back together. If I had time in a test, I certainly would do that to make sure I had a 100. Alright, 18. So look at that garbage in there. It's a very messy looking problem. It definitely has a GCF. Let's take it out. Look at what's common to both terms, an x squared. So we'll take that out. X squared times, let's see, these cancel. 16, and these cancel, minus y to the fourth. That definitely is different to 2 squares. The square root of 16. The square root of 16 is 4. The square root of y to the fourth is y squared. Square root of 16 is 4. The square root of y to the fourth is y squared. Remember, we divide the exponent by 2. You put plus minus in there. The order in which you have the plus and minus does not matter. Now, before we stop, take a look. That is different to 2 squares. You can take the square root of 4, you can take the square root of y squared, and we'll do that right now. So let's see. Square root of 4 is 2. Square root of y squared is y. Throw plus minus in there, and then this 4 plus y squared just carries down. So look at how big that answer is. What a nasty answer. 4 plus y squared, why can't we factor that? There's a good question for your summary. Alright, last but not least, a to the fourth minus 10a squared plus 9. There's no number in front of a to the fourth except for 1. There's no a after the 9. So as far as I can tell, there's no way to factor out a GCF. So let's get right into our puzzle. AC is 9, B is negative 10. Factors of 9 that add to be negative 10 are negative 9 and negative 1. So we'll go a to the fourth minus 9a squared minus 1a squared plus 9. Alright. Notice how I adjusted for the fact that it was a to the fourth, not just a squared. I kept my a squareds here with the negative 9 and the negative 1. Alright, so let's factor GCF out of these two. We have a squared comes out. You're left with a squared minus 9. Look at that. Difference of 2 squares. Over here, we want to change the sign, so we want to have a negative 1 in front of the 9 here. So we're going to take negative 1 out of this. Which will leave us a squared minus 9 as well. So we have a squared minus 9 times a squared minus 1, and do we have any difference of 2 squares? You can take the square root of a squared, you can take the square root of negative 9, and you can take the square root of negative 1. So both of these can be factored again. Wow. There's the first one. And there's the second one. A plus 3 times a minus 3 times a plus 1 times a minus 1 are the factors of a to the fourth minus 10a squared plus 9. That's it for today's lesson. Just as a little reward for watching, if you take a look at my webpage and go all the way down to the bottom, this is a little secret, secrets. You'll notice summary, factoring completely, right here at the very bottom of the files list. That is a summary on this lesson that you can use to get credit for that, or you could write your own. Have a wonderful day, and we'll see you tomorrow.